Okay, so we did this in class on Monday, May 6th also. Depending on which class you're in, we didn't get the whole way through all the notes for a couple of classes. But I'm going to do the whole front or the whole page of these notes just to have them done. So we're still talking about solving quadratics. So quadratics are those functions that have an x squared as the largest exponent in them. And we've talked a lot about how to find the zeros. We use the quadratic formula to find the zeros. We factored to find the zeros, and that's great. But there's another important part of the graph of a quadratic function, and that's the vertex. So the vertex is going to be the relative minimum or relative maximum of the parabola, depending on whether it opens upward like this or it opens downward. So in this case, this particular parabola has a relative minimum. So the vertex is down here at the bottom at 1, -2. If it were flipped over, then it would have a relative maximum. It also happens to be the point at the symmetrical middle of a parabola. So if we could fold this perfectly in half through the vertex, we would end up just putting one side of the graph onto the other side. So why is this important? When you are asked questions to find about, say, finding the maximum height or the maximum revenue, maximum profit, or the minimum height or minimum revenue or minimum cost, or anytime you're asked to find the maximum or minimum, what you're being asked to find is the vertex, because the y-coordinate of the vertex is going to be the maximum height or the minimum height or whatever it is you're looking for. It also happens to be the spot where the graph changes either from increasing to decreasing, or in this case, vice versa, it changes from decreasing and goes to increasing. So we're going to do this we're going to turn a regular standard form quadratic function like this one right here, or in this case it's an expression, into a vertex form quadratic, which looks like this right here. So we do that by completing the square, which just means that we're making some mathematical adjustments to a standard form quadratic so that it ends up being the result of squaring a binomial. So in this way, we can do a couple of things. We can solve it by taking square roots, and then we also get the vertex form of a quadratic. So we're going to focus on the vertex form right now because the vertex form is super useful. If you have your equation or your expression in vertex form, the vertex of the coordinates of the vertex of that graph are right there in the equation or in the expression. So this number right here is the opposite of the x coordinate in your vertex. So this number is +3. My x coordinate is going to be -3. This number right here is just the y coordinate. So if I was asked to find the maximum of the graph represented by this function or this expression, I could just say, well, the maximum is y = 7. Or in this case, it'd be the minimum, because this parabola would open upward. And if we want to take a look at what that looks like on the graph, we can do that right here. And the vertex of our graph is right here. And if we click that point, there we are at -3, 7. So that's the vertex of our graph. In this case, the lowest point that our graph reaches. Okay, so take a second, pause this video, and go ahead and complete the problem over here, and then come back and check. All right, so you should have gotten the vertex at +7, -5. And if we look at the graph of this function, or this expression, our vertex is right here, and we're at 7, -5. All right, so the process of completing the square is kind of a tedious process, but there's literally no algebra involved at all. We don't use any variables or anything. We just use the numbers that are in the expression to start with. So the first thing that we're going to do is rewrite the expression using parentheses. We're going to put C, which 7 is C. Let's remind ourselves of our A, B, and C. 7 is C. We're going to put C outside the parentheses, and then we're going to add a blank space inside and then subtract a blank space outside. So that's a little weird, but I'll show you what that looks like. So in the parentheses, 2x squared plus 4x, I'm going to add a blank space on the inside. I'm going to put 7 on the outside, and then I'm going to subtract a blank space on the outside. So what we're doing is we're working on getting this set of parentheses down to an expression that can be turned into a binomial squared. So we have to kind of move these numbers around, because with 7, 4, and 2, that won't work. We can't just do that. But we can make it do that if we plug in the right numbers. So go ahead and take a second and rewrite your expression the same way. Okay, so if you did yours correctly, you should have 3x squared plus 9x plus blank on the inside of the parentheses, and then plus 5 minus blank on the outside. So we add and subtract two things that are equivalent. Now notice I didn't say the same. We add and subtract two things that are equivalent. So what that means is we're going to put some number strategically inside the parentheses, and then we're going to subtract its equivalent on the outside. Now, remember, equivalent doesn't mean exactly the same. If I give you a $20 bill and then you give me two $10 bills back, you've given me back something different than what I gave you, but it's equivalent. And also, if I'm adding to your money and then you're subtracting the same amount of money, your amount of money hasn't changed either. So if we add and subtract the same amount, even if they look different, we still end up right back where we started, and we haven't changed the value of anything. So now, for step 2, I'm going to divide A out of the terms left in the parentheses. Now notice I didn't say divide A if you can. Divide A if it goes evenly. Divide A. You might get a fraction, you might get a decimal, but you're going to divide A out no matter what. So if I divide out A, I'm going to divide all of these terms by 2. And I realize there's no number right here, but I want to put that in there to remind myself later that I divided that number by 2 along with the other things inside the parentheses. So what I get is a 2 on the outside of the parentheses, x squared plus 2x plus some mystery number on the inside of the parentheses, and then 7 minus a blank space on the outside. So you go ahead and pause the video real quick, do step 2 on your side. All right, so A on this side is 3. And so I'm going to divide all 3 terms inside the parentheses, even the mystery term, by 3, just so we remember that we did that. 3 goes on the outside of the parentheses. Okay. Now, this is where you have to really pay attention to the details of what you're doing. So step 3 says take half of your new B. So our new B is 2x. Half of our new B is 1. And square it. So 1 squared equals 1. You're going to write this number in the blank space inside the parentheses. So 2x squared plus 2x plus 1 plus 7 minus blank space. So you go ahead and do your side, pause the video for a second, do your side, and then see if you get the same thing I did. I will warn you, you're going to get either a fraction or a decimal. Which one you get doesn't matter, but either a fraction or a decimal. Okay, so if you cut 3 in half, you get 1.5, or you get 3 halves. And then if you square it, you either get 2.25 or I'll write it underneath here. I'm not rewriting the whole thing. So if you square 3 halves, you get 9/4. So you could have 2.25 or you could have 9/4. All right, so the next step is to multiply the number that you got in step 3. So this number by the A that you divided out. Because remember, up here, what was originally here wasn't going to be 1. We divided out a 2. So what actually goes in here is 1 times 2. So 1 times 2 is 2. And that's what goes in this space over here. So when we rewrite that, we have 2x squared plus 2x plus 1, and then we're going to do plus 7 minus 2 in this case. So go ahead and do yours over here and come back and check. All right, so what you get is 6.75 if you do 3 times 2.25. The other thing that you might get here is 27/4. So I'll put that down here for those of you working on that in fractions. So 27/4. And then this would have been 9/4 if you were doing fractions. I'm a little squished, sorry. Okay, so now this step 5, there really should be like a step 5A and a step 5B, but we're going to do both of them at the same time. So now it says combine your terms outside of the parentheses. So if I do 7 minus 2, I'm going to have a 5 outside the parentheses. So I've got 2x squared plus 2x plus 1 plus 5. Okay? Now, this is starting to look a lot like this up here, but I need this to become a binomial. So it's going to become a binomial. It's like a magic trick. Okay, you remember that number where we did half of this number and then squared it? We're going to take half of this number and that's going to go inside of our parentheses. Or sorry, that shouldn't be an x squared. So instead of having this here, we take half of b again and just put it right there inside, put it right there inside the parentheses. And now we've changed this to this. If you don't believe that that works, go ahead and do x plus 1 squared, which is x plus 1 times x plus 1. And you get x squared plus 2x plus 1, I promise. Okay, so now go ahead and go over here and you're going to do your, say, step 5A and 5B. Okay, so when you combine your two terms over here, you get 1.75 or 7/4. So you would end up with 3 outside the parentheses, and then x squared plus 3x plus 2.25, and then outside the parentheses minus 1.75, or 9/4 minus 7/4 out here. And then remember, this number right here comes from half of b. So half of b is 1.5. So on the outside of the parentheses, we have 3. Inside the parentheses is x plus 1.5. And then squared minus 1.75. So from there, we can get our vertex. So the vertex here, remember, is the opposite of this number, so -1, and then this is our y coordinate, so -1, 5. So pause for a second, write down your vertex, and then come back and check. All right, so you should have gotten -1.5 and -1.75 as the coordinates for your vertex. So I want to take a look at the graph for my equation. So the graph for my equation, the original was y equals 2x squared plus 4x plus 7. And we said that our vertex was at -1, 5. So if we look right here, you have to get it exactly in the right spot. There's our vertex, -1, 5. And then if I go over here, I take off this equation and I can put on the other one. So this was your equation. And if we go down here to the vertex, we get -1.5, -1.75. So you can always use your graphing tool, like I like Desmos. You can always use your graphing tool to go check your answer when you're finished. So yours will be on the back. We have some more expressions, some of which have negative numbers in the front. If your A is negative, you divide by negative. So like I said, in step 2, divide out A. Always divide out A, even if you end up with a fraction. And if A is negative, you divide out the negative. So I'm going to give you the answers to these, but I'm not going to show you the work. All right, so the answer for the first one is going to be 1, -11. The second one is going to be 1, -7. Down here will be 1, 9, and over here will be 1, 8. Okay, and be sure if you weren't here on Monday, May 6th, to watch the other video on solving systems of equations through elimination.